Chapter 7, Exercise 7.43. Balance this reaction. This is dinitrogen pentaoxide. How do we balance this equation? Usually I balance one element at a time, and I always start with the most complex formula. In this reaction, N2O5 is the most complex formula. So I'm gonna just set alpha to be 1 to start with. Beta, I don't know. Gamma, I don't know. Now let's look at the reaction. If we have 1 N2O5, then we have 2 nitrogen atoms and 5 oxygen atoms on the left hand side. That means we need 2 nitrogen atoms and 5 oxygen atoms on the right hand side as well. First, let's look at nitrogen, which is easier because nitrogen appears only once on the right hand side in this formula, NO2. If alpha is 1, then we have 2 nitrogen atoms on the left. We need 2 nitrogen atoms on the right. Beta has to be 2. Now if beta is 2, we have 2 times 2, 4 oxygen atoms in this NO2 molecules. And then how much is this gamma? We have 5 oxygen atoms on the left, 4 oxygen atoms in this NO2 molecules. So this gamma O2 contributes 1 oxygen atom. So this has to be 1/2. Now we need the lowest ratio of integers. So I multiply every coefficient by 2. So this is going to be 2, this is going to be 4, and this is going to be 1. The last number times 2 is 1. And submit. Those are balanced. Of course, after you balance the chemical equation, plug in 2, 4, and 1 here, and count the number of nitrogen atoms, count the number of oxygen atoms. Make sure they are indeed balanced. Part B. Calculate how many moles of O2 form when 1.6 moles of N2O5 completely react. We'll just look at the ratio between O2 and N2O5. Now let's look at the ratio. So every 2 moles of N2O5 can produce 1 mole of N2. So it's going to be just 1/2 of the number of moles of N2O5. 1.6 divided by 2. That would be the correct answer. Again, you can see every 2 moles of N2O5 you get 1 mole of O2. What if the actual amount is 1.6 moles? Well, just divided by 2 or multiplied by 1/2. Part C. Calculate how many moles of O2 forms when 2.4 moles of N2O5 completely react. This is fairly easy. Alright, it's just 2.4 divided by 2. Similar to part C, it's just 1.2 moles. This is a slightly trickier question. We're not getting the number of moles of N2O5. Instead, we have the mass. But it's easy enough to determine the number of moles of N2O5. We do need the molar mass of N2O5. Nitrogen is 14, oxygen is 16, and we have 5 of them. Now 32 divided by the molar mass of N2O5, we have the number of moles, and then divided by 2. That's it. We get the number of moles of oxygen. So again, 32 is the mass of N2O5. And over here, this is the molecular formula mass of N2O5, 2 nitrogen, 5 oxygen. So on top over here, inside this pair of parentheses, we have the number of moles of N2O5. Divided by 2, we get the number of moles of oxygen. Alright, so Mastering Chemistry did the numerical calculation here. Oh, part E. This is the last part. We have 1.99 kilogram. So similar calculation, we have 1.99 and then divided by, actually it's 1990 grams, and divided by 2 times 14, 2 nitrogen, 5 oxygen, and then divided by 2, we have this expression as the number of moles of oxygen gas. Alright, that's it.